Graphing compound linear inequalities. So remember that there's a couple things that we have to keep in mind when we're graphing compound linear inequalities. The first thing is whether or not we're using solid or dashed lines. So if we have a less than or equal to, or a greater than or equal to, then these get graphed with a solid line because they're inclusive. We want everything, in the first one where it says less than or equal to, we've got two conditions. Either it can be less than something or equal to something. And it's the equal portion that tells us to use the solid line. If we have strictly less than or strictly greater than, then we're going to use a dashed line, because we don't want things that are equal, and things that are equal lie on the line. So we dash it to show that we don't want any of the solutions that lie on the line. So the other thing that we need to keep in mind is whether we're shading above or below, right? So if we have y is less than something, then we shade below. And if we have y is greater, we shade above. The other thing is what we do in terms of linear inequalities that have the or statement versus the ones that have the and statement. So or tells us that we want the entire shaded region. This means that we want everything that was shaded by one graph or the other. So when we're finished, the entire region that got shaded at least once. We can also have and statements, which are the intersection, and this is where we just want the overlap of the shaded regions. So I'll say overlap of shaded regions. Alright, so with all that in mind, we'll go ahead and get started. So in example 1, it says x plus 3y is greater than or equal to 3, or x is less than or equal to negative 2. So the first thing I need to do is make sure that I have it in the slope-intercept form. And remember, slope-intercept form is going to be something like this. Y is less than or equal to mx plus b, or we could have y is greater than or equal to mx plus b, or we could have y is strictly less than mx plus b, or y is strictly greater than mx plus b, depending on the inequality. But we want the y by itself on the left-hand side. In order to accomplish that, the first thing I'm going to do is subtract x from both sides. That'll give me 3y is greater than or equal to negative x plus 3. And then what I want to do is divide all of these terms by 3 to get y by itself. So that gives me y is greater than or equal to, now that negative x is really a negative 1x, so that's negative 1/3 x plus 1. Which tells me that my slope m is equal to negative 1/3, and my y-intercept is 0, 1. Alright, so let's go ahead and graph this. I start at x is 0 and y is 1, so that's that point right here. And then I'm going to use my slope, so that's going to be my rise is negative 1 and my run is 3. So a rise of negative 1 means go down 1 and then to the right 3. 1, 2, 3. And then I can graph as many of these points as I want to get a nice straight line. So I go down 1 and then over 1, 2, 3. 1, 2, 3. I can also go back to my y-intercept of 0, 1 and run this backwards. So I could go up 1 and to the left 3. 1, 2, 3. And then up 1 and to the left 3 again. 1, 2, 3. So my line, which will be a solid line, because it's greater than or equal to, draw that in. And then I have to decide which way to shade. Well, when I look at it, it says y is greater, so that tells me I'm going to shade above. And I want to be real careful at how I shade this, because I don't want to make it too dark. I'll get lost in my shading. Alright, so now on to the next condition, which just says x is less than or equal to negative 2. Well, if I look at just the second condition, right, because there's two conditions, x is less than negative 2 and x is equal to negative 2. Well, if I graph the equation x equals negative 2, that means I find negative 2 on the x-axis, and I'm actually going to want a vertical line because all of these points, the x-coordinate would be negative 2. And I'm going to be drawing a solid line because it's an inclusive inequality. So there's my solid line where it says x is equal to 2. Now this says x is less than or equal to 2. So if I look at my x-axis, I can see that all the points to the left, x is negative 3, x is negative 4, x is negative 5, those would all be less than negative 2. And that's what I want, less than or equal to. So I go ahead and shade after my line. Alright, so I've got my two regions shaded, and this is an OR compound linear inequality, which means union, which means I want the entire shaded region. So I might as well go through at this point and shade a little bit darker on the entire shaded region. That means I want everything that was shaded from the first inequality or the second. But I want absolutely everything. Alright, that's probably good enough. So any point that lies in that shaded region is going to satisfy one inequality or the other. And that's what we wanted to state. In our second example, we've got x plus y is less than 4. So the first thing I'm going to do is get this in slope-intercept form. So subtract x from both sides. And that'll give me y is less than negative x plus 4. Well, my coefficient here is a 1, so it's negative 1x plus 4, which tells me that my slope is negative 1, which I can write as negative 1 over 1, and my y-intercept is going to be 0, 4 from here. Alright, so I start at x is 0, y is 4, put a dot there, and now my rise and my run are negative 1 and 1. So I go down 1 over 1, put a point. Down 1 over 1, put a point. And we can just keep doing this until we have as many points graphed as we want. The more points we put down, the easier it'll be to draw a straight line. Next, I look at it, and it's a strict inequality, strictly less than, not less than or equal to. So I'm going to use a dashed line. And then finally, when I look at the y portion, it says y is less. Since it says y is less, I want to shade below this line. Once again, taking care not to shade too darkly on the first pass. Alright, second inequality, 3x plus y is less than 9. So I need to subtract 3x from both sides. That gives me y is less than negative 3x plus 9. Now notice that if I go to pull off my slope, that's negative 3, which I can write as negative 3 over 1, and my y-intercept is 0, 9. And we don't have 9 on our y scale. So what I would suggest doing whenever this happens is that you just create your little x, y table. And I'm going to rewrite this as if it were an equation. So I will write y equals negative 3x plus 9. And you just choose a convenient point for x and then solve for y, and that will give you a point. So when I look at negative 3 times x plus 9, I would like this to work out nicely. So I choose x is 3. This way, when I plug in 3 for x, I'm going to get y is equal to negative 9 plus 9. So y is equal to 0. So I'm not going to use this y-intercept 0, 9. What I'm going to use instead is the point where x is 3 and y is 0. So I go to x is 3, y is 0. That's this point right here. And now I will use my slope. Rise over run. So my rise is negative 3, so I go down 3, 1, 2, 3, and then I go over 1 and put my point. And then I can do it again. 1, 2, 3, over 1, put my point. Now I'm going to do the same thing in reverse. So I start at the point 3, 0 again, but instead of going down 1 and to the right 3, I'm going to go, down 3 and to the right 1, I'm going to go up 3, 1, 2, 3, and to the left 1. And then up 3, 1, 2, 3, and to the left 1. Now once again, this is says y is less. So this is a strict inequality. So we want to do a dashed line. Alright, and since it's y is less, we're going to shade below this line. So very carefully and lightly shade below the line. Now, this is an AND compound inequality, which means it's the intersection. If it's just the intersection, we only want where the two shaded regions overlap. And that's going to be where this cross-hatching occurs. And you can kind of see it underneath our two lines. So I'm going to go ahead now and shade this in more darkly. We want everything that occurs in that cross-hatched region where our two shaded regions overlap. And once we get that shaded in nice and dark, we'll be done. There we go. Notice that that didn't get included because it was only shaded by one of our inequalities. And that did not get shaded either because it was only shaded by one of our inequalities. This area up in here, it didn't get shaded because it didn't even get shaded once. So we only wanted that region that was shaded both times.